medium 3 with respect to 2 is 3 by 2. You have to find out refractive index of medium 3 with respect to medium 1. ठीक है नमन भानु अदन्य which is given correct answer. So let's discuss it. ठीक है. So now, if I'm saying refractive index of medium 2 with respect to 1, that means speed of light in 1 upon speed of light in 2. Refractive index of medium 3 with respect to 2 means refractive index of medium 2 upon speed of light in medium 2 upon speed of light in medium 1. Okay. So if you do like this, you'll get here. If I take the product of the two, it will be equal to refractive index of 1 upon refractive index of 2 into refractive index of 2 upon refractive index of 3. That means refractive twice. Sorry. What I'm saying. Refractive index of 2 with respect to 1 into refractive index of medium 3 with respect to 2 can be given as speed of light in 1 upon speed of light in 2 into speed of light in medium 2 upon speed of light in medium 1. So that is speed of light in 1 upon speed of light in medium 3. It can also be given as in terms of refractive index of medium 3 with respect to medium 1. So we get this relation that in this way the relation we follow. So we get here that 4 by 3 into 3 by 2. That is equal to refractive index of medium 3 with respect to medium 1. Okay. That is the result. Now, say this is a surface on which a ray is incident at an angle of 60 degrees. Okay. Medium 1 is air, and the refractive index of air is taken as 1. Medium 2 has a refractive index of root 3. Okay. So you have to find angle of deviation experienced by this ray. Find angle of deviation experienced by this ray. Let's see what happens. Yes, Aditya, correct. You are correct. In the last class, we discussed the relation for this angle of deviation. And what was the relation? What was the relation? Angle of deviation in case of refraction is I minus R. Where R here is angle of refraction. Okay. So that means we need to find out angle of refraction here. Okay. So how can we do that? Using Snell's law. Okay. Snell's law. We'll get 1 into sin 60. Okay, 1 is refractive index of medium 1. Okay, into sine of angle the ray makes in that medium will be equal to refractive index of medium 2. That means root 3 into sin R. Okay. Now what is value of sin 60? Sin 60 is root 3 by 2. So that will be root 3 sin R, or equals to, when you cancel it, it will be 1 by 2. So that will be equal to sin factor. Get here R equals to 30 degrees. So now angle of deviation is I minus R, that is 60 minus 30. 30 degrees.
Why is the formula written in the point?
Because in case say R is greater than I, in that case again we'll take the value only. That final division will be R minus I. That is.
Yes.
Next question is, on the surface, one medium A is medium 1 here. Yeah, it is incident, and angle of incidence is 30 degrees. Okay. First medium has refractive index of 2, and second medium has refractive index of 1. Again, you have to find angle of deviation. This way. Okay. Ahana, correct answer. Ritesh, correct answer. Ajaz, correct answer. Janvi, correct. Ayush, correct. Vishwa, correct answer. That's correct. Now, using Snell's law, we get root 2 into sine 30 into 1 by 2 equals to 1 into sine. That means this will come out to sine 45. So giving us r equals to 45 degree. Now we can easily find out delta, which is equal to mod of I minus r. Since here r is greater, so that means we'll keep the value as 45 minus 30, so answer will be 15 degree. Okay? Question clear? Sure. Now, okay. Okay. Done. Now, say there is a medium in the form of a sphere. Okay? A sphere having refractive index of root 3. Okay? Now, say O is the center of the sphere and a ray is incident at an angle of 60 degree. Okay? You have to find out the net deviation. Find net deviation by the ray when it comes back. Yes, sir. Okay, this is your question. Outer medium is here, so refractive index is 1. Refractive index of the sphere medium is 2.
And for which side is the it is equal to 3?
Complete sphere, the medium of the sphere is, this sphere is made up of certain medium. So refractive index of that medium is 2. So let's discuss this. Yes, Agarni, your answer is correct. Bhanu, correct answer. So let's discuss it. Now, okay, angle is 60 degree. Now say this point is B. So using Snell's law at A, okay, we'll get 1 into sine 60 equals to root 3 into sine r. And by solving it, we'll get r equals to 30 degree. I can say this clear to everyone. R will be 30 degree. Yes, sir. So this is at point A. That means this ray will get reflected at an angle of 30 degree. Now, we know that normal will always pass to the center of the sphere. So this angle is 30 degree. Now, if I have to draw where the normal at the other end, we know that this normal should also pass through center only, like this. Okay, and so I name this point as B. Okay, so we need to know what is this angle of incidence on the other side at point B. Now, if I take this triangle AOB, OA will be equal to OB because both are the radius of the sphere. So it makes an isosceles triangle, and we know for isosceles triangle the angles will be, corresponding angles will be same. So that means this angle will be 30 degree. Okay, so if it is 30 degree, the ray will, we now get that what is angle of incidence at point B? It is 30. Now again using Snell's law at point B, so at P, using Snell's law I'll get root 3 into sine 30 to be equal to 1 into sine r. Okay, so root 3 into 1 by 2 equals to 1 into sine r. Root 3 by 2 is actually sine 60, so here r comes out to be 60 degree. So that means the rays will emerge out making an angle of 60 degree with a normal. Okay, now let's find out the deviation. So to find deviation, as we have done in case of mirrors also, we need to know, because there are more than one surfaces, so here we need to know that in which sense the deviation happens. This is deviation of the first phase, and here is the deviation happening on the second phase. So delta 1 equals to I minus r, so which is equal to 60 minus 30, that is equal to 30 degree, and it is happening in clockwise sense. Okay, and delta 2, which is happening at point B, if you find out, it will be again I minus r. So 30 minus 60 will take the mod value, that means 30, and the sense in which it is turning is again clockwise. So both are turning in the same sense, therefore net deviation will be equal to delta 1 plus delta 2, that is equal to 30 plus 30 equals to 60 degree in clockwise. So finally we find that the ray has turned, deviated by an angle of 60 degree in clockwise. Okay, when it passes through this sphere. Is this point clear? Now, all of you written the solution?
Just a minute.
Okay.
minus lambda.
Okay. Let's do one more question here. Okay, refractive index. A pole, there's a pole, okay, and height of the pole is 4 meters from the bottom of the lake. So this is the lake. And there is this pole, okay, and it is 1 meter above the water surface. Okay. So overall length of the pole is 4 meters, and length above water is 1 meter. Okay. This is refractive index of water is 4/3. Okay. And say the sun rays are falling making an angle of 45 with the verticals. The sun rays are falling on the mirror, sorry, on the pole, making an angle of 45 with the vertical. Okay. So we have to determine the length of the shadow of the pole on the bottom of the lake. Find the length of shadow of pole on the bottom of the lake. There is here of refractive index 1. So our question is here. I'm again repeating. This is the pole. We start from the bed of the lake, and height of the pole is 4 meters, and it is 1 meter above the water level. Refractive index of water is 4/3, and air is 1. You have to find out the length of the shadow of the pole on the bottom of the lake if rays are falling at an angle of 45 degrees on the pole with the vertical. Okay. First of all, trace the path of the ray, what is the path of the ray. Then we know that shadow is the reason where they land on the bottom of the lake, and then start tracing it. Which is incident on the water surface, and as it is moving from air to water, it will bend towards the land. Like this. So this is a path followed by the ray. Let's draw the normal at the point of incident. Okay. This is normal at the point of incident. Now, if this angle is 45, we can find out the angle at which the ray will get reflected using Snell's law at the point of incidence. We are naming this point as A. So using Snell's law at A, at point A, we'll get 1 into sine 45 equals to 4/3 into sine R. Right? Sine 45 means 1/3. So I can write it as equals to 4/3 sine R, or I'll get sine R equals to 3/4 root. Right? And we know that sine is the ratio of perpendicular upon hypotenuse. Okay. So if there is a triangle, making an angle R, okay. So its perpendicular is 3, hypotenuse is 4 root 2. So you can find out the value of base. Value of base will be 4 root 2 square minus 3 square. Right? Solve it. So 16 into 2. 32 minus 9. 32 minus 9 will be 23. No? Root of 2. So the base comes out to the root of 23. Okay. So we get it. Now let's start solving. We know that the length of the shadow is this. So this is the pole, point O, this is normal N, and here the point ray falls or to the bottom, take this point is P. So that means length of the shadow will be OB. So we get here length of shadow is OB. That means ON plus N. Now, we know that this angle is 45. So if this angle is 45, length and base both will be, height and base both will be equal in magnitude. So this is 45, this is also 45, these two will be same in magnitude. So from here we get that ON equals to.
Could you repeat again?
Now since this angle is 45, this angle will also be 45. This right angle triangle.
Yes, ma'am.
So isosceles triangle, so the corresponding sides will also be equal. So this is 1, so this one also be 1. And these two are parallel, so that means ON is also equal to 1. 1 here.
Yes.
Now we have to find out the value of NB. So first to find NB, I know this. I know the length of side is AN, which is equal to 3 meters, and I need to find out NB. And I know what is value R. So that means if I know these two sides, the trigonometric ratio which I should use should be tan. So tan of angle R from this triangle from triangle A and B can be given as perpendicular, that is NB, upon base, that is AN. Right? So my first, from here I'll get NB equals to AN into tan R. And AN is what? 3. AN is 3 into tan of R. Now we need to know what is the tan of angle R. Now for that I'll refer to this triangle which I've drawn, which I've got the value from this, from the Snell's law. Now that this triangle is making an angle R, we have got the values of all the two sides. So now I can from this triangle find out what is the value of tan R. Tan R means, if I name it as PQR, then in this triangle, tan R will be given as the ratio of perpendicular, that means PQ, upon base, that is QR. PQ is 3, QR is root 23. So now I can put the value of tan R from here in the equation. So it will be 3 into 3 by root 23. So it will be 9 by root of 23. So I've got the value of OB and also got the value of NB. So length of shadow becomes will be equal to 1 plus 9 by root 23. Meter. You can further, if you want, you can do the calculation to find out the final answer. Is this question clear? Now this method which we have used here, keep this thing in mind, because in many questions you have to approach it similarly. You might get some questions in this. If you are not getting the exact value of angle while solving the trigonometric ratio, you will be approaching the question using this. You will draw a triangle using the whatever sides ratio you are having, and then accordingly you can substitute the value whatever situation is needed. Solution is clear to everyone?
Ma'am, in the given figure, where exactly does the triangle PQR come?
No, PQR is not coming exactly in the figure. Now, do you know the concept of figure, trigonometry?
Yeah, ma'am.
It works on similar triangles.
Okay. Understood.
That's what I'm saying, that you should remember this concept at this point, because in many places to solve the problem you have to use this approach.
But why root 23 is equal to NB, right, sir?
Root 23 is equal to N, no, not NB. Root 23 is equal to QR. Look, see here, these two are similar triangles. That means triangle A and B and triangle PQR are similar triangles. They are not exactly same triangles. Don't get confused. Corresponding to side PQ, in that triangle is side NB. And corresponding to side QR, in our triangle is side AN. So they are similar triangles. So since the sides are having different values, it appears that the value of AN is 3 and PQ is also 3. But they are two different sides. In one triangle it is base and the other triangle is perpendicular.
Yes, sir.
If all of you have done this, solution is clear to everyone how we have approached the question. So now, after this, let's practice single reflection from the plane surface. Reflection on the plane surface.
Ma'am, in the last step for tan R, again we're going to the diagram only. The diagram we need.
Yeah.
PQR.
Yes, we can. Because from the triangle A and B, we are getting what is the value of tan R. Tan R can be given as the ratio of sides NB and AN. So we put the value. We need to know AN. Yeah. We need to find out the value of NB. So we have the value of AN, but we need to know what should be the value of tan R also. To find out the value of tan R, we'll be referring the triangle PQR.
Yes.
Okay?
Yes.
So all of you have written the solution? Now write on the heading single reflection from plane surface. Single reflection from plane surface. Okay. So now we know that because of refraction we see some phenomena like bending of pencil at the interface of water and glass. When we put the pencil in the glass and fill it with water, we see at the interface the pencil will appear to be broken. Okay. So the position and the how the image is formed will be different. So let's discuss this scenario only. But in the case of pencil and water, we are seeing the we are seeing the glass obliquely. But here, what we will be discussing, in this case, we are specifically the result is be considered only if the rays are falling normally on the interface. So let's discuss this one first. Say this is an interface which is separating two media. Say one media is real medium, and the second one is a tensor medium. Its refractive index is NR and its refractive index is ND. Okay. And say there is an object kept in the tensor medium. An observer from rarer medium wants to see this object. Now, the rays coming from the object that reaches the eye of the observer, person will be able to see the image of the object. We know this. So a ray which say falls normally on the interface will go straight, but a ray which is at a certain angle will experience reflection. Since it is moving from a denser to a rarer medium, the ray will bend away from the normal like this. This is the path of the ray. Now, if there is an observer observing this object from this rarer medium, which is the eye of the observer, for the observer, these two rays are, it appears to start from this point. These two rays appear to start from this point, where the image of the object appears to the object. That means actually the object is at this much depth below the interface, but the depth of the object which appears to the observer is less. Or we can say for the observer, the apparent depth of the object will be less than its actual depth or real depth. So this is a real depth.
And why is it so?
Because of reflection. As you have seen that because of the bending of light, this thing happens. Because for the observer, we don't know that whether the light is bending or not. For us, from wherever the rays are coming, just in front of it, we'll see that okay, the point where the rays appear to be starting from is the point where our mind makes the image of the object. Okay, so since rays are coming towards the eye in such a way that to the eye it appears that rays are starting from this point. Therefore, for the eye, image or object appears to be at this position. Okay, so this is the apparent position of the object. The position which appears to the eye. Or apparent position of the object. Why this is happening? I think so. It is clear that it is because of the refraction of the light which happens at the interface. Okay. Similarly, if the reverse case happens, that means your object is in a rarer medium and the observation of the observer is in the denser medium. So that means the observer is observing, looking at an object which is kept in a rarer medium. Then what will happen? So let's draw the case here.
Ma'am, so normal rays do not get refracted?
Yeah, when the rays are falling normally on the interface, they will not bend. Okay. So bending won't happen.
Yes.
Then in two cases, you can write down these two points here. Okay. That when light moves from travels from one transparent medium to other, it will not bend under two conditions. First condition is that angle of incidence is zero. Or we can say ray is incident normally at the interface. Okay? Ray is incident normally at the interface. Okay? We are discussing the case of reflection without bending. The ray will pass from one transparent medium to another, but no bending will take place. And the second case is if refractive index of medium 1 equals refractive index of medium 2. If this happens that both the mediums have same refractive index, here again, when the light travels from one medium to another, no bending will take place. The light will not bend. These are the two conditions when the light moves from one medium to another, it will go straight without bending. Okay. So now let's come back here. So this is the interface separating two media, rarer and denser, refractive index NR and NB. And now in this case, my object is kept in the rarer medium. This is my object. Ray, which is normal at the interface, will go straight without bending, and the ray which is moving from rarer to denser will bend towards the normal. Like this.
मेरा फोन चार्ज में लगा दी, उसको लाइट नहीं आएगी। मेरा फोन चार्ज है ना, हटा दी चार्ज में से।
And these rays reach the eye of the observer.
फोन आता चार्ज में सही है।
The ray appears to start from this point. Where the image of the object is found. This is the point where the image of the object is found. Okay. So, this was the actual height of the object. This is real height. And this is the height which appears to the observer. That is, this is the apparent height. So, one thing is clear to us from the figure. I think everyone is getting this thing. That whenever the object which is kept inside the denser medium is observed from the rarer medium, it gets displaced towards the interface, and if the object is kept in a rarer medium and is being observed from the denser medium, it shifts away from the interface. Okay? So in one case, just wait. So, yes, we were discussing this thing that when the object is observed from the rarer medium, it will bend, it will shift towards the interface, and when it is observed from a denser medium, it will shift away from the interface. Okay? This point is clear to everyone. So, if you have, and the second important thing, we have to, whatever the calculation we'll be doing, you have to remember that we are doing it for the normal incidence. Please write down this term up here, that all the calculations are true for normal incidence. Okay? So, the results which we discuss are true for the normal incidence and not for the oblique incidence. That means we assume that you are observing the object just directly from the top of it. That means rays which are coming from the object are more or less normal at the interface. You are not observing it from one side. That means this is not the case that say the object is kept over here and you are observing from this side. ठीक है, this is not the case. We are not discussing this. That means wherever the object is, we are just observing from the top of it. ठीक है, got it? So let's do the calculation thing now. Here, or should I give direct formula? Tell me. You can even directly write it down that apparent depth upon real depth will be equal to here n r upon n. ठीक है, that means, or you can write down 1 upon n dr. ठीक है, simply you can remember like this, that in this case, first case, apparent depth will be given as real depth upon refractive index of denser with respect to error, because refractive index of denser medium with respect to error medium will be greater than 1. So since the image shift towards the interface, so that means the depth will decrease. So the apparent depth will be real depth divided by the refractive index of denser with respect to error, because the value will decrease. ठीक है, in the second case you can simply remember in the reverse way, that is apparent height upon real height equals to nd by nr. ठीक है, or I can say that apparent